This is 7.1 of Algebra. So we're going to start looking at exponents. Anytime you take a number, a non-zero number, so 3, 7, 92, 1,000, negative 400, negative 73, anything that's not zero, whenever you take a number that's not zero and you put it to the 0th power, right, so like a to the 0 here, you get 1. So 4 to the 0 is 1. Negative 3 to the 0 is 1. 5.14 to the 0 is 1. The other thing is that if we have a negative exponent, so like negative n, a to the negative n, to get rid of that we need to make it positive, and we need to move it to the bottom of a fraction. So if you have 7 to the negative 3, you can bring it into the bottom of a fraction and we get 1 over 7 to the third. If you have negative 5 to the negative 2, you can bring it down to the bottom and your exponent becomes positive. The number, the negative 5, is still negative. So if we take 3 to the 0, we get 1. If we take 2 to the 0, we get 1. If we take 1 to the 0, we get 1. So when we take 0 to the 0, we must get 1, right? But think about this. When we take 0 to the third, right, 0 times 0 times 0, we get 0. We take 0 squared, which is just 0 times 0, we get 0. 0 to the 1 is just 0. So then 0 to the 0 is 0? We've got a problem here because these are both the same, 0 to the 0. And one we get 1, and for the other we get 0. It's not possible to have those both equaling 1 and 0, so 0 to the 0 is undefined. 0 to the 0 is undefined. There is no answer to it. Okay, so let's simplify some powers. Let's start with this one here. Negative 5 to the 0. Anything to the 0 is 1. So this is just 1. Okay, now let's look at some of these negative exponents. So to get rid of that negative exponent, I need to bring it to the bottom of the fraction, right? Technically right now, this is in the top of a fraction, right? I could stick this over 1. That doesn't change the number. It's technically in the top of the fraction. We need to bring it to the bottom of the fraction. So 1 over 4, and it makes it positive. So 4 to the third. 4 to the third is 4 times 4 times 4. 4 times 4 is 16. And 16 times 4 is 64. So this is the same thing as 1 over 64. Let's try this one. I need to make the exponent positive, so I need to bring it to the bottom of a fraction. So 3, and now my exponent turns positive, so 3 squared. Same thing as 3 squared is 9, so 1/9. 6 to the negative 1, we need to bring it into the bottom again, so this is 6 to the positive 1. Anything to the power of 1 is just itself, so this is 1/6. And finally, if I bring this negative 4 down to the bottom, I get negative 4 squared. Negative 4 times negative 4 is a positive 16. Anytime you have a negative number and you bring it to an even exponent, right? So like negative 4 squared, negative 4 to the 4th, negative 4 to the 6th, your answer is going to be positive. Okay, because a negative times a negative is a positive. This is different. So one side note, negative 4 squared, that's negative 4 times negative 4, which is 16. That's different than negative 4 squared. Okay, if you don't have the parentheses, you do this part first. 4 squared is 16. And then you take this, you make it negative. So this would be a negative 16. If you type this into your calculator and you don't use parentheses, it's not going to come out right, right? If this is what you mean to do, you need to put those parentheses in there. Or you need to know in your head that whatever your answer is, it needs to be positive because you have an even exponent. Okay, so it's a little bit trickier. We're going to use some variables. So x to the negative 9th, stick it into the bottom of a fraction, we get x to the 9th. Okay, check this guy out. Looks a little different than this one, right? Because it's already in the bottom. If it's already in the bottom, then we bring it to the top. I was always told cross the line, change the sign. So with this one, technically for A, this is technically over 1, right? Over 1 wouldn't change it. Dividing by 1 doesn't change the number. So we had to cross the fraction line and go to the bottom. Now we're going to do that same sort of thing, but now we're already in the bottom. We're going to move to the top. So this turns into n to the third over 1, right, to get it in the top. And that's just the same thing as n to the third. We don't need to divide by 1. Okay, let's look at this one. What needs to move? We don't want negative exponents, so we need to move this c to the negative third. So the 4 and the b are going to stay on top, and that c to the negative third needs to move to the bottom so that we get c to the positive third. Okay, d, we need to move this a to the negative 3 up to the top. So the 2 is already on top. And we'll bring a to the third. It turns into a positive 3. It's technically over 1, but we can simplify that. That's just 2a to the third. And then e, our negative exponent, is the one that needs to be moving. So n to the negative 5 needs to move. So m squared stays on the bottom, and we need to move the n to the negative 5 down. So we get m squared n to the 5th. Alrighty, so now we're going to evaluate these. We're going to plug in a number for them. My recommendation is simplify first and then substitute in. It makes your life so much easier. So let's clear this out so we got some more room. Okay, let's look at a here. The n to the negative 4 is what needs to move. So we'll keep w to the 0 on top. We get n to the positive 4th. But w to the 0, anything to the 0 is just 1, right? So this turns into 1 over n to the 4th. And then we're told up here that n is equal to negative 2. So I get 1 over, I'm plugging in negative 2, don't forget your parentheses, negative 2 to the 4th. And then you can either do this on your calculator or you could do it by hand. You get negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2, that's 4. This is also 4. 4 times 4 is 16. So this is 1 over 16. Okay, let's look at this one. So the thing that needs to move is I need that n to the negative 1 to move. So that needs to move down, and the w squared is going to stay on the bottom. And then I need to move the n to the 1, which is just the same thing as 1 over w squared n. So let's plug in. W is 5, so this is 1 over 5 squared times negative 2. You can put the parentheses around the 5 if you want. Since it's positive, it's not going to change it. So this is 1 over 2. 5 squared is 25. Still times that negative 2, which equals 1 over negative 50. Alrighty, let's look at C. N to the 0 is just 1, so this turns into 1 over w to the 6th. So then when I plug in 5, I get 1 over 5 to the 6th. And if we do that on our calculator, we get 15,625. So this is 1 over 15,625. And our last one here, so the w is the thing that has that negative 1 on it. So the w to the negative 1 needs to move. So this means that our n will still be on the bottom. We'll bring w to the 1. W to the 1 is just w. So when we plug in, we get 5 over negative 2. Alrighty. Now we're going to do our got it problem for this story problem. It's a story problem, yes, but don't freak out. It's not that bad of a story problem because they already give us the equation. All we need to do is plug in these values. So we have the equation 5,400 times 3 to the w, and we're going to plug in w equals negative 2, w equals 0, and W equals 1. Okay, let's start with the negative 2. So 5,400 times 3 to the negative 2. Now, we want to get rid of that negative exponent, so we'll bring it to the bottom, right? So the 5,400 will stay on top. And we'll bring 3 squared to the bottom. Now it's positive. So this is 5,400 over 9. And when we divide 5,400 divided by 9, we get 600. Okay, now let's plug in 0. So 5,400 times 3 to the 0, that's just 5,400 times 1, right? So we get 5,400. And again, since this is a story problem, we're working with real life situation. It's talking about the populations of insects. And so W is standing for the number of weeks after the population was measured. So if we're plugging in 0, we're talking about right when it's measured, right? So when they measure the population, there's 5,400 insects. Can we have negative 2 weeks? No, not really, but in this case, you can think backwards, sort of, that if we had measured it 2 weeks ago, this is probably what it would have been. And now let's measure 1 week in advance. So 5,400 times 3 to the 1, which is just 5,400 times 3. When we do 5,400 times 3, we get 16,200 insects. And there's your homework.